Let's consider a special right triangle, that being the isosceles right triangle. So in an isosceles right triangle, we're going to assume that the two legs have the same length. So we've got a length here of A, and because this one will be equal, we will call that also A. And we have that the two legs are the same measure. Our right angle is going to be down here, and we're going to refer to this length over here as C. That's our hypotenuse of the right triangle. Now, what's so interesting about this particular triangle is that not only can you automatically decide on the side lengths, A and A are the same, C is the hypotenuse, and it must be longer than A and A. But because we know that the sum of the angles of a triangle are 180, and that the two other angles must be congruent because they open up to the faces or the legs that are A and A respectively, that means that this angle must be 45 degrees and this angle must be 45 degrees. That gives us what is commonly referred to as a 45-45-90 triangle. That becomes shorthand for what it really is, which is an isosceles right triangle. Now, in this particular situation, just because it's an isosceles right triangle doesn't mean that we can't still apply our understanding that we already have of the Pythagorean theorem. So normally the Pythagorean theorem looks like this, where the square of the two legs are summed or added, and they equal the square of the hypotenuse. But for this particular setup, we know that A is one of the legs and the other leg. So we can substitute out that second leg, knowing that the second leg in our example is going to be another A. Because we have A squared and A squared, we can add them together and call it 2A squared equals C. Solving for C, namely the hypotenuse, we can take a square root, and we get plus or minus the square root of 2A squared. Now, right out of the gate, we're going to automatically discount the negative solution. We're talking about the lengths of triangles, the lengths of the sides of a triangle. The negative solution is not going to be relevant to what we're doing. So really, we have just the one solution, the square root of 2A squared. Using what we know about radical expressions, we can simplify a little bit farther and say that C is going to be the square root of 2 times the square root of A squared. But the square root of A squared is just A, so we end up with the square root of 2 times A. So what we have here is a solution for the length of the hypotenuse of any isosceles right triangle. Namely, it's going to be the length of those legs times the square root of 2. And because we set this up and proved it in a generic form with A and knowing that the two legs were the same length, we know that this is going to work in any isosceles right triangle situation, any 45-45-90 situation. So should you encounter this type of triangle in any circumstance and you know the length of one of the legs, well, obviously that gives you the other leg, but then you can shorthand to multiplying by the square root of 2 in order to get the length of the hypotenuse.